everyone, and a very good day to all of you, to Dr. Fazila. I'm Tan Meng Han from Section 1, and now I would like to present about my programming part. Now come to our programming part. So before we run a program, we need to insert the math statement. So by integer get value for the double value, which is also means for the float, also means for the decimal value. So print the statement that enter the value of you want to find, whether 1 is for the open bell drive system and 2 is for the closed bell drive system. So scan F. F is for the format code for the float or the double for value. Then we return to it, and this I will use ABC to represent for the open bell drive and the closed bell drive system. Before we get into our function, we get float pi, E alpha beta, M the sleep, R is the radius, W the velocity, L1 L2 is the overall length belt, and X is the center distance between the shaft. So before we get into the function, we print a message that enter the value of a center distance between the shaft. So seems we will scan for the value we have entered by using the float and the decimal value of X. So this is our first function, which is ABC equal to 1, which is for the open bell drive system. This is our first loop for I equal to 0, I less than 2, and I plus plus. So before that, we will scan a message that enter the radius of the shaft. For this I plus 1 is for the integer before the I, which is mean by R1 and R2. So we also scan the float value. So alpha, this is the formula for the angle of length of open bell drive, and L2 is also the overall belt length for the open bell drives too. So next we will print a message that value of the overall length of the open bell drive is, this is a display for our overall belt length. This is the first one. So next for the second loop, same is to go to the I equal to 0, I less than 2, and I plus plus. So this is print message that lets you to enter the velocity of the shaft in the RPM, which is also mean for the revolution per minute. This is the unit for the velocity of the shaft. Same is equal to I plus 1, this is the integer for the W, and we will get W1 and W2. This is for the inserting the velocity. So same before that we scan the value of float. So by following the formula of a sleep, we get sleep percentage. This is our display, and I have limit the value of the percentage in 3 decimal point. So this is for the second function, and have you else if to represent for it. And this ABC equal to 2 is for the closed bell drive system. Same, we will use I equal to 0, I less than 2, I plus plus in order to inserting the radius of the shaft. Next we will use beta. This is the formula of the angle of belt for the closed bell drive system, and L2 is overall belt length formula for the closed bell drive L2. So next, after we inserting the radius value, we will get the value of overall belt length for the closed bell drive. This is L2. So next we will also go to another loop for the I equal to 0, I less than 2, and I plus plus. So we also we will enter the velocity of the shaft in RPM for the velocity 1 and velocity 2, and by following the formula we will also get the sleep percentage. In these two functions, we will only get the difference between the overall belt length, where we will get the sleep percentage is the same one, as the both of them, even for the different belt drive, they will have if they have the same velocity, they will have the same sleep percentage. So after the end of our program, we go back to the main integer n is the get value. This is for the value of 1 or 2 is for whether it's choosing open bell drive or a closed bell drive, and hence we return to 0. This is our end of our program. Thank you.